Welcome to this video lesson. To start, let us guess the word being presented in these pictures. Use the letters below as clues. What do you think is the word? The word is relationship. Let's take a look at each picture to understand why it has been chosen to represent relationship. The first one shows the symbiotic relationship between a sea anemone and a clownfish. This relationship is called mutualism. It's called mutualism because they benefit from each other. Next, a mother-child relationship, which I think is the most beautiful relationship in the world. How about this? This is a couple relationship. This is the goal of some of the youth today. Actually, this can be one of your goals when you're already at the right age or you're already mature enough. Fourth, angles? Seriously? Does that picture show relationship? Of course! Relationship also exists in angles. Do you remember what the first set of angles called? Angle 1 and angle 3 are called vertical angles. Angle 2 and angle 4 are also called vertical angles. They are formed by intersecting lines. Let's look at the next pair of angles. 60 degrees plus 120 degrees is equal to 180 degrees. What do you call such pair of angles? They are supplementary angles. How about the next one? 27 degrees plus 63 degrees is equal to 90 degrees. What are these angles called if they sum up to 90 degrees? They are called complementary angles. And lastly, angle 1 and angle 2 form a straight line or a straight angle. And they are adjacent with one another. So they are called linear pair. And since a straight angle measures 180 degrees, angle 1 and angle 2 are also supplementary. So we recall those relationships, and that will help us in our lesson today. Relationship between the interior angles and exterior angles of a polygon. Not only that, we will also study other things about interior angles and exterior angles of a polygon. So, let us read the objectives. In this video lesson, you shall be able to differentiate interior and exterior angles of a polygon. Determine the relationship between interior angles and exterior angles of a polygon. Find the formula for the sum of the measures of the interior angles of a convex polygon. Determine the sum of the measures of the exterior angles of a convex polygon. So let's begin. You have learned before that angles are formed at a vertex. That is why they are being named this way. What have you noticed about the location of the angles? Are they inside the polygon or outside the polygon? They are inside the polygon, and they are called interior angles. How about exterior angles? What are they? A side of a polygon can be extended to a point outside the polygon. So let's say side ON is extended to point S, which is outside the polygon. This forms an angle with another side of the polygon, side NQ. So this angle is called angle SNQ. And this is an exterior angle. Likewise, if we extend side NQ to point Y, which is also outside the polygon, a new angle is formed with side QP, and that's angle YQP. Also, if we extend side QP to point X outside the polygon, a new angle is formed with side OP, and that's angle OPX. Then, side PO can be extended to point U, forming a new angle with side ON, which is angle UON. As you can see, we also have 4 exterior angles for this polygon. So, based on what we have discussed, how will you differentiate interior angles and exterior angles of a polygon? An interior angle is an angle at the vertex of a polygon, inside the polygon, formed by 2 adjacent sides. An exterior angle is an angle at the vertex of a polygon, outside the polygon, formed by one side and the extension of an adjacent side. Can you differentiate them using your own words? Please write them down on your math journal. Now, let us look at the relationship that exists between the interior and the exterior angles of a polygon using this figure. So we have this exterior angle SNQ, and here's its adjacent interior angle ONQ. What relationship can you see between angle SNQ and angle ONQ? Wow! They form a linear pair! What does that mean about their measurements? Yes, the measure of the exterior angle and its adjacent interior angle are supplementary. So if angle ONQ measures 88 degrees, what is the measurement of angle SNQ? So that's 180 degrees minus 88 degrees. So angle SNQ is equal to 92 degrees. The same way with angle UON and angle PON. They also form a linear pair. So, if angle UON measures 90.5 degrees or 90 and 5/10 degrees, what is the measure of angle PON? The measure of angle PON is 89 and 5/10 degrees. Having these examples, what relationship can you conclude about the exterior angle and its adjacent interior angle? The exterior angle of a convex polygon is supplementary to its adjacent interior angle. So once you add their measurements, the sum will be equal to 180 degrees. Congratulations! You have determined the relationship between the exterior and the interior angle. Now, let us investigate the sum of the measures of the interior angles of a triangle. We have invited this investigator to work with us. Suppose we have this triangle with interior angles 1, 2, and 3. Yes, we can also name angles with numbers. Look what kind of angle will these three angles form? Observe. What kind of angle was formed? The angles formed a straight angle. So if these angles formed a straight angle, what is the sum of their measurements? The sum is 180 degrees. Therefore, what can you say about the sum of the measures of the interior angles of a triangle? The sum of the measures of the interior angles of a triangle is 180 degrees. Is this really important? Take a look at this. This is the truss bridge of the Southern Pacific Railroad in California for a single-track railway, but it has been converted to pedestrian use and pipeline support. Notice that this consists of triangles. How important is the accuracy of the measurements of the angles of the triangle? Yes, a balanced triangle provides good support for structures like this. That is why interior angle measurement and its sum is very important. Here are other truss bridges designs. Look how great triangles are. Now, what if this triangle is one of those in the truss bridges and you need to be accurate in measuring its angles? If angle 1 measures 88 degrees and angle 2 measures 48 degrees, what is the measure of angle 3? Let us use the formula for the sum of the interior angles of a triangle. 88 degrees plus 48 degrees plus the measure of angle 3 equals 180 degrees. The sum of 88 degrees and 48 degrees is 136 degrees. Applying addition property of equality, let us add negative 136 degrees to both sides of the equation. Positive 136 plus negative 136 is equal to 0. That is why measure of angle 3 is equal to 180 degrees minus 136 degrees. So what's the answer? The final answer is the measure of angle 3 is equal to 44 degrees. Yes, we have come up to a great conclusion about the sum of the interior angles of a triangle. How about the sum of the measures of the interior angles of other polygons? Let us again investigate. Now we need 2 investigators since this may be a tough one. Look carefully at the figures. Let us draw the diagonals of each polygon from one vertex only. Take note, from one vertex only. So for this quadrilateral, we have one diagonal from one vertex. Next, for the pentagon, we have 1, 2. And for the hexagon, or for this 6-sided polygon, we have 1, 2, and 3. For this heptagon, we have 1, 2, 3, 4. And for this octagon, we have 1, 2, 3, 4, and 5. Observe each of the figures. What polygon was formed when we drew the diagonals from one vertex? Triangles! Correct! Having that, let us now complete this table. So for the quadrilateral, how many sides does it have? It has 4 sides. And how many triangles are formed after we have drawn the diagonal? We have 1, 2. We have 2 triangles. Remember that the sum of the measures of the interior angles in a triangle is 180 degrees, right? Therefore, the sum of the measures of the interior angles of this quadrilateral is 2 multiplied by 180 degrees, since we have 2 triangles in it. How about for this pentagon? We have 5 sides. And how many triangles were formed? We have 3 triangles. So it means that the sum of the measures of the interior angles of a pentagon is 3 multiplied by 180 degrees. For the hexagon, let's continue. The number of triangles is 4. So the sum of the measures of the interior angles is 4 times 180 degrees. For the heptagon, 7 sides. We have 5 triangles, and the formula is 5 times 180 degrees. For the octagon, we have 8 sides and 6 triangles. So the sum of the measures of the interior angles of an octagon is 6 times 180 degrees. Now here's the challenge. What if you do not know the number of sides? So you represent the number of sides as n. What do you think is the number of triangles for a polygon with n sides? Observe each number of sides and each number of triangles formed. What do you think is the pattern that we can have so that we will be able to identify the number of triangles? 4 became 2, 5 became 3, 6 became 4, 7 became 5, 8 became 6. So, the number of triangles for a polygon with n number of sides is n minus 2. So the number of triangles formed in a polygon with n sides after having drawn the diagonal from one vertex is n minus 2. Therefore, we are going to multiply that by 180 degrees. The quantity n minus 2 multiplied by 180 degrees. Because of that, we can conclude that the formula in finding the sum of the measures of the interior angles of a convex polygon is the quantity n minus 2 multiplied by 180 degrees. It means that we have to subtract 2 from the number of sides, then multiply it by 180 degrees, and that's the sum of the measures of the interior angles of that polygon. If the sum of the measures of the interior angles of a triangle is important, is the sum of the measures of the interior angles of other polygons important too? This is the pentagon. Amazing structure, right? This is a pentagonal building constructed in 1941 to 1943 to centralize the headquarters of the War Department and the U.S. Navy. How important is the sum of the interior angles of a pentagon in the construction of that building? The accuracy of the measurements of the interior angles of the pentagon determines the safety and stability of the construction of the building. So let's now move on to the next part of the lesson. How can we determine the sum of the measures of the exterior angles of convex polygons? Help me in determining that sum by having a recall of some lessons or some things that we have previously learned. Remember that angles E, F, G, and H are exterior angles, And angles A, C, B, and D are the respective adjacent interior angles. Therefore, what is the sum of angle E and angle A? The sum of their measures is 180 degrees. Same thing with the measures of angles C and F. The sum of their measures is 180 degrees. Also, the measurement of angle B plus the measurement of angle G is equal to 180 degrees. And measure of angle D plus the measure of angle H is also equal to 180 degrees. Now, what if we add all of them? The sum of all those angles is 720 degrees. And since we have the commutative property of addition, do you remember that? That means we can have different order of the add-ins, we can group the interior angles, and we can group the exterior angles. The measure of the interior angles plus the measure of the exterior angles is equal to 720 degrees. We have known earlier that the sum of the interior angles of a quadrilateral is 2 multiplied by 180 degrees. So it means we can substitute 360 degrees with the sum of the interior angles. Therefore, the sum of the exterior angles is equal to 720 degrees minus 360 degrees. The sum of the exterior angles is equal to 360 degrees. And that's applicable to other polygons. So, the sum of the measures of the exterior angles of a convex polygon is 360 degrees. Remember that the sum of the exterior angles of a polygon is as important as the sum of the interior angles of a polygon. Let us now have the activity. Write inside the curved box the letter of the correct measure of the indicated angle. Those letters will complete the phrase blank capital of the Philippines. For additional 5 points, write down also the town in Rizal being referred to by that phrase. There you can see the missing measurements of the angles, and for the last part, you will identify the sum of the measures of the interior angles of a triangle and the sum of the measures of the exterior angles of a polygon. By answering that and by filling out the curved boxes with the correct letters from these choices, you are going to complete the phrase blank capital of the Philippines. And if you want additional 5 points, you will determine what is that blank capital of the Philippines in Rizal. I'll give you 10 minutes for this activity. So, let us now have the answer. That is Garments Capital of the Philippines. And what is that Garments Capital of the Philippines in Rizal? That is Taytay, Rizal. Being a Rizaleño, you must be aware that Taytay, Rizal is famous and is known as Garments Capital of the Philippines. It is also known as the Woodworks Capital of the Philippines, since it is also a good source of wooden furniture. So now let us reflect on your learning for this video lesson. I have these questions here. Which part of the lesson did you like the most and why? Which part did you find the most difficult? And what will you do to learn more about the lesson? Congratulations and thank you for attentively listening and watching the video. Bye!